Should have expected that from the title. Alright, everyone. Welcome to Stats Week 2. Good afternoon to everybody. Hopefully you were able to go over the content from last week. We are going to, with each week, I think I'm going to try to go back over just a little bit of refresher information because everything builds upon the previous week. So I want to make sure we do that, make sure we understand all these bits of the groundwork that we're laying for stats and then for your eventual project. There's a typo here. It's spring 2021, not 2020 anymore. So let's look at just a couple things to refresh ourselves. A blank is a subset pulled from a blank with the goal of ultimately using the people, objects, or places in the blank as a way to generalize to the blank. A lot of blanks there. Take a minute to think about that. So the correct answers are: a sample is a subset pulled from a population with the goal of ultimately using the people, objects, and places in the sample as a way to generalize to the population. Remember, research we do outside of the U.S. Census is not going to include a complete population. Therefore, we have to take a sample. We have to take a smaller representative grouping of the same people, objects, places, make a conclusion about that group of people that we can then generalize back to the greater population. Research includes two types of variables: the blank, which is the cause, and the blank, which is the effect. The two types of variables we will be talking about: independent and dependent variable, also known as predictor variable and outcome variable. We're looking to see how, so we kind of consider these to be cause and effect. So we're looking to see how the independent variable affects the outcome variable, affects the unit of analysis. Hypotheses attempt to predict. We didn't go over this too much, but the relationship between two variables with a null hypothesis representing no relationship. So that is in the PowerPoint. We'll talk about hypotheses a little bit later on, but there is such a, we talked about a hypothesis, and there is a general hypothesis that every type of research question is going to have, which is a null hypothesis, meaning that there's no relationship between the two variables you are, the independent variable and the dependent variable. So sometimes that finding of no relationship is as important as an actual finding of a relationship, okay? Because you may be looking at two different variables that you think are connected very deeply, like political affiliation and opinion of capital punishment. You might think those are directly related, and then you find that there is no relationship. So that's a very interesting finding in and of itself. The blank of blank is the object or target of the research study. For example, people, court cases, criminal incidents, etc. That would be the units of analysis, or unit of analysis. We are going to be measuring how the independent variable affects those units of analysis. When we're talking about surveys, it's people, and then in criminal justice we can talk about cases, we can talk about police departments, we can talk about correctional facilities, prisons. So a good start. Again, we want to build upon all that material as we go. We're going to look at types of variables and levels of measurement this week. So we have two basic levels of measurement. Two basic groups of levels of measurement, four total: categorical and continuous. Within the categorical group is nominal and ordinal, and then within continuous is interval and ratio. Levels of measurement just simply mean the different ways in which we are measuring the variables, because not all variables are the same. We have some that are more numerically based, which are continuous, like age weight, number of arrests, population, number of murders in a year. And then we have categorical that aren't really based on numbers, they're based on groups. So a lot of demographics, race, sex, political affiliation, sex, gender, religion. So demographics, and then also kind of other groups like class in school, different areas, places, city, different organizations. If we're talking about criminal justice research, type of organization, whether it's a federal level, in the state level. So there are different things we do with different types of, different levels of measurement, rather. And I'll go through these pretty quickly. I think I'll just leave that there. People can see it pretty well. Again, we have the two groupings, and so with categorical variables, we have nominal and ordinal. Nominal are your traditional classification of places, objects into different groups, where there isn't really a particular order or ability to rank something. So an example I gave early on is pretty consistent example. Demographics, if you think about, if you're looking at gender and you look at male and female and possibly a non-binary category, there's no ranking that can take place within those variables. If you look at race, there's no ranking that can take place. Any ranking is going to be arbitrary. If you want to do alphabetical or something like that, you can rank those, but that's really just keeping them in order. You're not ranking them specifically. State of, the state you were born in, country you were born in, those are variables that are nominal. There's no order to them whatsoever. But we see those very frequently. Those are going to be involved almost always in any type of survey or other information, because we use demographics to lay groundwork for some of the analysis we do, because we know that there are a lot of differences based on demographics in our society. The other categorical variable is ordinal. So again, it's a classification of people, groups, objects, but this time we can put them in an order and we can rank them. This can sometimes show up on a survey where we have what we call like a Likert scale, however you want to pronounce it, where it goes strongly agree to strongly disagree, 1 through 5, and then there's different measures in between. So the difference here is that we can put a rank or an order to them. So they're basically nominal variables, but there's some order to them based on maybe severity, based on age, based on time, something like that. Whatever is placing an order and rank in them. You can look specifically at rank, like if you want to use position in a police department, rank or something like that. That can be specifically placed in an order. If you want to look at severity of felonies, right? We have different levels of felonies. You can go murder, acts 1, 2, 3, 4. Those are ordinal. There's the 1, 2, 3, 4, for instance, are not numeric. They don't have a numeric value to them. You can't do any type of computation with those numbers. They represent something. So they're basically a group, even though they have a number attached to them. Year in school, freshman, sophomore, junior, senior. Those are groups. They have no numeric value. Even if you look at, 9, 10, 11, 12 as the representative values, those don't have actual values. They're just kind of placeholders for different groups. Now, the two continuous variables, interval and ratio, they're very similar. They're often used the same way. Actually, SPSS, the program we're going to use a little bit later, it really combines them into a ratio variable. And because intervals are kind of, there isn't much difference. They're both quantitative, they're both continuous, they have numeric values. Intervals don't have a real 0 point, and they're usually kind of arbitrary, but they have numbers to them like temperature and things like that, and there's a specific interval value between them, while ratio values can have partial integers, can have decimal points and things like that. So the ratio variable is going to be, the very basic numeric variable, frequency of anything, so number of arrests, number of murders, number of individuals incarcerated, number of people on in a caseload. Those are all criminal justice examples. But then age, weight, height. IQ is more of an interval example because it's not an actual value. It's a value that we've kind of subjectively given to something. But any traditional number value that you think of is going to be a ratio value. And ratio value is considered kind of the highest level. So whenever possible, if you can do something, like if you wanted to use age as a variable, it's best to use the raw value, right? The raw age, and you can just keep it to years, but it's better to do that as opposed to using something like an ordinal variable of using child, adolescent, young adult, adult, middle-aged, senior citizen. Those are all age-based variables, but they're a different level of measurement. Those would be ordinal. So you can always turn a ratio variable into an ordinal variable, but you can't do the opposite. So if possible, it's best to use the highest level of variable, if that makes sense. You'll get the best results, most precise. Okay, let's take a look at some examples. We'll go through them, think about them as I go through them with you. I'll give you the answer. We'll talk about it in discussion this week. Let's look at, let's give it a shot, as I say. Suspect's race. So there could be a number of different options here, but let's just go with the four kind of traditional criminal justice system descriptors: white, black, Latino, Latina, Latinx, other. So I mentioned this as an example already, but that would be a traditional nominal variable. Most demographics are going to fall into that range, but that's a group of people. There's no value to that. There's no specific numeric value to any of those groups, and you can't place them in an order. You could do anything you did would be arbitrary. If you wanted to do alphabetical or something to that effect, then that would just be arbitrary. So there's no order to them. Next, the age at which an offender was arrested for the first time. So given that information present in this example, that's going to be a ratio. Age at its raw value, unless it's grouped into something else, is going to be a ratio. That's whether it's in years, it's traditionally in years, but even if you do it in days, or if you did decades, that would be a little different, right? If you talked about somebody in their 20s, somebody in their 30s, that's not real. That's not the raw data for age. That's already been grouped then into a categorical variable. Next example: sentences received by convicted defendants. As an example, jail, prison, probation, fine, or other. Take a minute to look over that. That one's a little more complicated. Some might make the argument that it would be ordinal. However, I would say it would be nominal. Remember, ordinal and nominal are going to be measuring the same type of variable, group of people, places, object, whatever. But ordinal involves a rank and order to it. So these 5 different sentences presented, there's not really an order you can place. Some people might see this as type of a way you could order these based on severity, but not exactly. That's maybe a little subjective as well. Some people might say probation and prison are definitely different and jail is different, but the way you rank them, you could maybe rank them, through a level of secure detention or something like that, but is 30 days in jail, is that more severe than 2 years on probation? I don't know. That's debatable. So that's something to keep in mind too. If you ever have a concern about whether there's really a rank or order to them, it might be best to just consider them to be nominal. A lot of the different statistical analyses you can do are ones that you can do with categorical. So you could do nominal or interval. Excuse me, nominal or ordinal. Total number of status offenses that adult offenders reported having committed as juveniles. I'm going to go through these a little faster. There's a lot of information there. It's kind of just a lot of fluff. The total number of status offenses is a total raw number, so it's going to be a ratio. It doesn't really matter if we're talking about adult offenders versus juveniles and the categories there. This is just dealing with total number of status offenses reported. The amount of money in dollars that a police department collects annually from drug asset forfeitures. Very similar, same thing. We're talking about the amount of money in dollars, so we're looking at raw numbers. Unless we grouped it somehow, this is just a standard ratio variable. Prison security level, minimum, medium, maximum. You could even throw a super max in there if you want. You could even throw house, you could throw, well, we'll leave it at minimum. We'll leave that at the lowest. So these are different categories. This is a categorical. There's no numeric value to them, although we can see an order to them, right? Minimum, medium, maximum, supermax. That goes in ranked order of increased security level, or increased security detention. Trial judge's gender. That's pretty basic too. Most demographics, except age perhaps, is going to be nominal. Gender is nominal. There's no rank that can be applied to it. Hopefully that makes sense to everybody. It's important to understand the different levels of measurement for different variables. At the very least, understanding what's categorical and continuous, because you can only do certain types of statistical analyses and different tests, which we're going to get to later on, based on the level of measurement. So there are some that you can do chi-square, for instance, we do with categorical variables. If you have a continuous variable, you couldn't do a chi-square. You could go through the process, you could do it in SPSS. It would give you results that appear to be correct, but they wouldn't really mean anything. We'll talk about all that a little bit later. So we also have measures of central tendency. So these are referred to in your book, so it gets a little confusing, so I want to point something out to people. All three of these, the mean, median, and mode, which I'm guessing people have heard of before, you've probably talked about them a little bit in 294. In the book we're using, it refers to all three of these as averages. They're all three are different kinds of averages, and that's a little confusing because the mean, the first one we're going to talk about, is traditionally referred to as the average. It's the arithmetic average, the average based in arithmetic. So that's a little confusing, so just keep that in mind as we go through. But these different averages are used to give you basically a measurement of the sample of values you have. So I'll get into how they're used differently for different levels of measurement, but often they're used for, mode is used for nominal, but everything else is not going to be used for nominal. And I'll talk about that in a moment. But having a measure of central tendency gives us a better idea of the most common type of case we have in this sample of cases. If we have 50 students and we want to know the age in general of the students, we don't take all 50 ages and then evaluate them all independently and keep those in our mind. What we do is we get an average, so we have a good understanding of, on average, what age are we dealing with. And so there are different, the mean is the arithmetic average, but these other measures of central tendency also represent the average in different ways. So like I said, the mean is going to be the simple arithmetic average. Can be calculated with continuous variables. It can't be used for categorical variables. Now, when we get into SPSS, and I'll mention this right now, when we get into SPSS, we'll use numbers to represent, numbers with values like 1 through 5 to represent different categorical variables. And within SPSS, we can do something like get the mean, get the average, and then use that to represent something, mainly if we're doing ordinal variables. But otherwise, we wouldn't really use the mean for categorical variables. And so we'll get to that a little bit later. So we use every raw score, every value within the sample set to come up with the mean. And I think people know in general, I had my notes on what the actual values are. I have them later on in the presentation, I think. But to get the mean, we take all of these values, we take the sum of all these values, which I believe is somewhere around like 1700 or something like that. We take the value, the sum of all of these values, and then we divide it by the n, the lowercase n, which represents the number of cases within that sample. And just looking at this, I believe it's 30, right? 5 by 6. So we take the total sum of all the values, divide it by 30, and then we obtain the mean, which let's just say it's 55 or something around there. I have it later on in the presentation, but so that's a basic average, as an average that you've probably known for years. Median is a little different. Median is actually looking at the midpoint of the set of scores. So it's kind of considered the 50th percentile. It's a value that half of the scores are greater than that value and half of the scores are less than that value. So that's a little bit different. It still gives you a good idea of what's most representative. It can give you a good idea of what's a good representation of the age of a group of people, but it's used. I'll tell you in a second, but it's usually used when we have, some outliers, meaning that let's say we have 50 or 30 different values. 28 of them are kind of all around the same area. We have, it's a college class, and most people are in their 20s, young 20s or so. And then we have outliers. We have one kid who's a high school student who's taking college courses, and then we have somebody who has decided to go back after they've retired and they're 60 years old or something. Those people are outliers. If we look at the mean, then we include everybody, right? And those outliers are going to move the measure of central tendency one way or the other, depending on how large one is. And some would argue that's not exactly the representative value, because most people are 20 in the class, but we have one person who's 60, so that's going to throw things off a little high. That's going to elevate that measure of central tendency. So what we do then with the median is we basically look at a positional value. We say, if we put these all in order, which one's in the middle? Because then it doesn't matter if the highest age in this case is 60 or if the highest age is 24. It's still going to be the same value right in the middle. So that's something to do to kind of weed out outliers. So for instance, if we take the same set of values here, the first step we have to do, we can't just look at what's in the middle here and say, 65 is in the middle or 4 is in the middle. That's not exactly what we mean by in the middle. So we have to put them in order. In this situation, 1 through 500. And you can see, just looking at the values, that 1's not really an outlier, but 500 seems like it might be a bit of an outlier. And if there are 2 cases in this situation, I think the 44 and 45, since there's 30, there's no true middle, right? Only odd numbers would have a true middle. So if there's 30 values, then there's 15 and 15. So I believe I have the a slide later, but I believe it's 44 and 45. And if that's the case, you take the middle. You take the average of that. So it'd be 44 and a half, I believe. I have the values later. Mode is the simplest of the three measures of central tendency. There's no mathematics involved necessarily. It's the most frequently occurring value. So it can be used on continuous data, as I'll show you, but it's not really that informative. So it's mainly used with categorical variable, because if you remember, with nominal, you can't really do anything with them, with those groups. You can't really put them in order. They have no numeric value. With, excuse me, with ordinal, you can put them in an order, so you could, to a certain degree, get a median out of them, but otherwise, you can't really do a lot with categorical variables besides the mode. So it's going to be the most frequently occurring. Like I said, in this situation, we can still do a mode with numbers, and we can see a couple different. In this situation, and I'll go to the next slide. There's a few different numbers that actually repeat. So let's look at what we found for all three of these. Like I said, I had the numbers. So if you think back, the mean by summing all the values, dividing them by n, it gave us 56.83. So that's going to be the arithmetic average of all those values involved. The median, I mentioned this, and that was correct, 44.5. Once we put them all into order, we had 44 and 45 as the central values. So we took the average there. And then if we look at mode, we see a few different, which I believe each of those values had a frequency of 2, meaning that our sample set had 15 twice, 32 twice, 44, 65, and 78 all twice. So all of those were equally frequent as the most frequent, and so they're all in mode. So something to consider here, we have these different values, and if we have this sample set of 30 different values, and we say, I want the measure of central tendency, I want the best representation of the values within this sample set, depending on which measure we use, we can have some very different outcomes. Even if we disregard mode, because we know if we're just dealing with numbers, we're not going to use mode. But if we look at mean and median, there's a big difference there. And we know that the big difference, if you remember back to the data set, the difference is because of that 500 value. That was the outlier for all the other values. There wasn't, I think all the other values were below 100. So, go back to this for a second. So the 500 we can see affected the center point basically of those values. And there's a couple different arguments that can be made, and some of it is just kind of looking at the situation. People in favor of the mean in this situation can say we need to do the mean because we need to take into consideration that 500. Even if it is an outlier, it's still part of this data set. And I just gave random numbers, so it really depends on what you're looking at. But people who argue for the median can say that yes, it is part of the sample set, but it's really not consistent. It's not part of the pattern that we have. It's not a consistent part of this pattern that we're trying to understand. So it's part of the group, but it's an outlier. So we shouldn't have it affect it because, in this situation, it affects it by 12, whatever it is we're analyzing. So there's arguments that can be made for both situations, and it really comes down to the research being done, the situation itself, to try to determine which is the best measure of central tendency to use. And we'll go over a couple examples in a moment so we can see what those differences might be. I think I basically covered this. Mode we're going to use for qualitative, categorical, nominal. It can be used in certain situations for ordinal perhaps, but it's not always the best the best time. If you have extreme scores, outliers, again, if you feel like it's a situation where you need to use a median, use one. Usually we hear median being used when we talk about income because we have, and some people might argue that that's not really the best thing to do, but we have some people who are the 1% or whatever that have an enormous amount of wealth, and if we were to use the mean to determine the financial economic status of people in the U.S., it might be influenced heavily by some of those high numbers, and that wouldn't give a accurate representation. So that's when we see median being used a lot. And the mean incorporates those extreme scores as well. So here's a little bit of a breakdown, kind of what I mentioned before. If we're looking at nominal, and I combined interval and ratio because those are the continuous variables that we kind of group together. When you're looking at nominal variables, you want to focus on the mode. You can't do the mean at all because there are no values, and you can't do median because you can't put an order to them. Remember, median is kind of a positional value. It's not exactly a value, it's just the value that happens to be in a certain position, if that makes sense. So if we have nominal variables that you can't place in order, then you can't determine the middle point if you can't put them in any type of order. So we don't really want to use the mean for ordinal because it's a categorical variable, but however, like I was saying with SPSS, we can give numeric values to these based on an order. And the thing about that is they have to be a kind of standard order. The Likert scale that I was talking about before, if we have an ordinal variable that uses a 1 through 5, strongly disagree to strongly agree, those are going to be standard across all responses. So we could do a mean, and if we had a mean of 3.5, we could see where that falls in position in that ordinal. It would be, if your 3 is neutral, then you'd be, I guess, more likely to, agree than disagree. So you can do that on SPSS to a certain degree, but median and mode definitely you can use. And then with interval, you can use all of these with continuous variables like I demonstrated in our examples, but the mode is not going to be very helpful at all. The mean and the median are definitely going to be more helpful, and in some situations using the mode for continuous variables is just going to be more confusing. As you saw, we had 5 different values. So unless there's some very odd situation, you're not going to use mode for continuous variables. So let's look at a couple examples. Let's give it a shot. In these situations, would we use the mean, the median, or the mode? A survey item asks, how many times have you shoplifted, and allows the individual to fill in an appropriate number. So some of these are survey questions. So based on the setup of that question, how many times have you shoplifted? Each individual can just fill in an appropriate number. You're not choosing from a number, you're not choosing a category or a group or some other categorical variable. So this appears it'll be a continuous variable. So if that's the case, you'd want to use the mean or the median. You can also, you can look at the data, those data once you receive them, to see if you should use the mean or median. You might have an idea up front that maybe you should use the mean or median, but in this situation, if you have 100 people and 95 of them have shoplifted, one time, and then there's one individual who has shoplifted 100 times, that's going to throw things off a lot. So you might want to take that into consideration, maybe use the median. The survey item asks, have you ever shoplifted, and allows them to circle yes or no. So same type of question, same theme, I suppose, but it's a little bit different. This is not a open answer. This is choosing yes or no. Choosing yes or no, there might be a prefer not to answer option. Either way, this is a categorical variable. It appears to be nominal too, unless there's some other answer involved in there. So you could put it in a specific order, but otherwise, it looks like mode is going to be what you're going to look at. Out of 100, 75 said no, 25 said yes. You're just looking at the frequency, which is said the most no in that situation would be the specific measure of central tendency through the mode. A researcher wants to know how many times the average inmates have been arrested. So just based on this question, it looks like continuous. And this would probably be a good use of mean. We know that we're looking at inmates, so they're people who have been arrested at least one time. Chances are they've been arrested a few times because we have a lot of repeat offenders, so there might not be too many outliers. You'd probably get a pretty good measure of central tendency, an idea of how many times inmates have been arrested by looking at the mean. And finally, a U.S. researcher wants an idea of how many deaths on average resulted from terrorist activity yearly from 1990 to 2010. Complicated question, right? If it's complicated, that usually means I'm trying to have you think about something critically. So it might appear, I'll go through this quickly, it might appear just off the top of your head, probably wouldn't want to do mode. Looking at a 20-year span, 21-year span. Mean could work. That would definitely give you the average, and that's what you want. You want the average. Something, though, to consider, as I talked about, looking at kind of the context of the research, the context of the question being asked, that might be necessary to determine the difference between using a mean and a median. Now, if you look at terrorist activity, U.S. deaths from terrorist activity, pretty low, generally speaking, especially foreign terrorists, not necessarily domestic terrorists, but especially foreign terrorists. However, there have been some examples of that. And one of those examples is 9/11, 2001. So that would fall into that range. So if you were to look at the yearly number of deaths from terrorist activity in that year range, it would be pretty consistent until 2001. Then you'd see a huge spike of around 3,000 people. So if you use that over 20 years, you might get an average of 150 or whatever it would be. So that would be very misleading because on average each year we don't have 150 people dying from terrorist activity in the U.S. It's just that that 1 year heavily influenced the average. So in this situation, a median would probably be the better option. Oops. So that's actually the last slide for this week. This is important for you to know for quizzes and a test and whatnot, but if you don't understand the correct level of measurement, you can't use the right measure of central tendency. And if you don't understand those, you're not going to be representing data the right way, and you're not going to understand data the right way either. So these are important, and they will come in handy for, like I said, quizzes and tests, as well as your final project that you do. Okay, so we'll go over this. I know this is kind of complicated, and I introduced a lot of it, so make sure you read back over the other PowerPoint, go over your book information, and then we'll discuss some more of this during class. So that's it. Take care, everyone. I don't have a funny outgoing thing to do, so whatever. So I'll see everybody on Thursday. Take care. Thought it froze. Probably that was just a funny outgoing thing I came up with at the end. Kind of funny. Kind of funny thing. See you Thursday. I don't have a funny outgoing thing to do, so whatever.